Alright guys, today we're going to be taking a look at similarity. Alright, so we've already spoken about congruence. Today we are going to take a look at similarity or similar figures. Alright, so your title is Similarity. Again, fold your paper to the margin just so that you can have the kind of halfway point. In the far margin, you're going to write down similar, since that's what we're talking about. All right, so what does it mean to be similar? Put very, very simply, similar just simply means you're looking at the same shape. You're looking at the same shape with the same angles. And this is very important, the sides are proportional. Alright, so your similar simply means the same shape, the same angles, and the sides are proportional. In regards to what we've just come from looking at, which is congruent, would have the same shape, same angles, and the same sides. The only difference between similar and congruent is that the sides are proportional, but everything else is the same. Okay, now very, 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 very important, your order of how you set up your proportions must be the same. Order must be the same. Okay, and you'll understand what we mean by that when we take a look at an example. So similar, same shape, same angle, sides are proportional, and the order must be the same. So let's take a look at an example. All right, so an example, let's go ahead and just draw like a little rectangle, make it 10, 8, draw a larger rectangle, make it 12, and X. Okay, so again, remember similar, same shape, so they're both a rectangle, same angles, they're all 90 degrees, but the sides are proportional because the sides are not equal. If the sides were equal, it would be congruent. All right, so let's take a look at an example. We're saying that these are similar figures. What is X? So these are similar figures. What is X? So you have to set up a proportion. Now there are many, 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 many ways of setting up a proportion. I'm going to talk to you about 4, but then I'm going to stick to 1. Okay, so to set up a proportion, you can look at it from side to side. All right, from side to side, and this is what this means. What is the side that goes with 8 over here? Is it 12 or is it X? All right, it's X. All right, so 8 goes with X. So you could set it up from side to side. 8 goes with X. Now, this is very, very important. If you start from here, from this side, you have to start from that same shape again. So you can't go 8 goes with X and then say 12 goes with 10. You have to say 10 goes with 12. Okay, so 8 goes with X. That means you have to start from this side. 10 goes with 12. All right, that's how you set up a proportion. Or, all right, it doesn't matter. Again, that's why I said you have like 4 different ways, and then I'm going to stick to just 1. All right, but I just want to go ahead and show you all of them just so that you're good. What if I wanted to start from this side? I can. Side to side, comparing sides to sides. So this side goes with this side. So 12 to 10. Now again, if I started from this shape, I have to do it again. The order must be the same. So if I started from this side, what would I put down here? All right, very good. X, and X goes with, good, 8. I just want to show you that no matter how you decide to go, you're going to still get the same answer. Once you have it set up like this is solving proportions, you should have covered this up in 7th grade, 8th grade. But again, just to refresh your memory, anytime you have proportions like this, all you need to do is cross multiply. Okay, so you do 12 times 8, which is 96, equals 10 times X, which is 10X. Then once you have it set up like that, what do? You got divide by 10. So X equals 9.6. Okay, I'm going to show you that no matter how you set up the proportion, it's going to be exactly the same. So let's do this side. Cross multiply. So 8 times 12 is 96 equals X times 10 is 10X. Then what do? Very good. Divide by 10. So X equals 9.6. See how they're exactly the same? All right. Doesn't matter how you set it up as long as the order is the same. Okay, the order is the same. All right, so we looked at from side to side. This is not the only proportions that you could set up. You could actually set up from what I call figure to figure. Again, it doesn't really matter which one you do, just pick one, okay? But after I show you all of them, I'm going to just pick one, and I'll stick to one for every example that I ever do. All right, so figure to figure. That means you can compare. Again, the order still has to be the same. Okay, so from figure to figure, that means I'm going to look at this figure only and then compare it to this figure. So doesn't matter what order. Again, I'll do both. All right, I'm going to look at this figure, and I like to start with the smallest number. So small to big, 8 to 10. So 8 to 10. Now remember, whichever order I started with here, I have to start with the same order on the other side. So I have to go the smaller number, then the bigger number. All right, the smaller number is X, and then the bigger number is 12. Or I can start off with the bigger number to the smaller number. Doesn't matter as long as the order is the same. So bigger number to smaller. So 10 to 8. But if I started from the bigger to smaller on that side, on this side I have to start from bigger to smaller. So 12 to X. Okay. Again, I just want to show you that all of them are going to work as long as the order is the same. If the order is the same, you'll always be right. So cross multiply. 12 times 8 is 96 equals X times 10 is 10X. Divide by 10. X equals 9.6. Right, same thing here. Cross multiply. X times 10 is 10X equals 12 times 8 is 96. Divide by 10. X equals 9.6. Again, it does not matter which method you pick, whether you're comparing from side to side or figure to figure. Okay, you're still going to get the same answer if your order is the same. So again, let me say this again. Order has to be the same. So whatever you start from, make sure you stay consistent. Order must be the same. Again, similar, same shape, same angles, sides are proportional. Well, we have to add on to what we've already done in class. So what we're going to do is look in at proofs. Okay, with the proof theorems and the postulates, we're going to look at also for similar. So you're going to just continue down. Of course, I run out of space because I'm doing it with a marker. But still the same thing. In the margin, all right, you're going to write down proven, all right, proven similarity. Proven similarity, okay. And unlike before where you could have any combination except donkey forwards, donkey backwards, or AAA batteries, we're only going to look at three things. We're going to look at AA, okay, AA, and that means what? Angle, angle, all right? And all that means is if two angles are the same, it's similar. So if two angles are the same, it's similar. The exact same two angles, of course. AAA, angle, angle. If two angles are similar, are the same, then it's similar. All right. The other one we're going to take a look at is SAS. I'm sorry. SAS. All right. And what's that? Side, angle, side. Just like before. So side, angle, side. Now the only difference is when you're looking at similarity, the sides are not the same. The sides are proportional. Sides are proportional. Whereas before they were congruent, because we're talking about congruency. When we're talking about similarity, you're always talking about sides are proportional. So sides are proportional and the angle is the same. Okay, so sides are proportional, angles are the same. And we'll take a look at an example so that you can see what these mean. And finally, the last one is side, side, side. Now before, if they had all three equal sides, the two triangles were congruent. But in this case, remember, because we're talking about similarity, it's the sides have to be proportional. So if all three sides are proportional, then the triangles are similar. Okay, so this stands for side, side, side. All right, perfect. So that's it in terms of notes. What I'm going to do right now is just walk you through some examples that we're going to do together in class, as well as you complete on your own.